The most beautiful thing we can experience is the mysterious. Albert Einstein. Chapter 1, An Ordinary Day, an extraordinary signal in the world of quantum computing. Breakthroughs usually come in fractions, faster calculations, more stable qubits, slightly improved error correction. But one recent experiment at a leading quantum research facility, a division within a major tech conglomerate, yielded something no one expected. The experiment began like countless others before it. A 53-qubit quantum processor, operating at near absolute zero, was tasked with simulating quantum fluctuations from the very earliest moments of the universe, the tiny, turbulent fractions of a second after the Big Bang. The objective? Simple. Explore possible pathways for how order emerged from chaos. But what appeared on the researchers' monitors was not chaos. It was structure. At first glance, it resembled a geometric ripple, elegant, symmetrical, yet far too stable to be a random fluctuation. The engineers double-checked their systems. Visualization bug. Power surge. Some obscure processing artifact. They reset the system. And the pattern appeared again. Chapter 2, The Repeating Enigma. Now curious, and slightly unnerved, the research team repeated the experiment. Full system reset. Quantum memory wiped. Cooling cycle re-initiated. All parameters randomized. And again. The pattern returned. But this time, it was slightly different. More intricate. As though it had evolved. Again and again they ran the simulation, and each time the structure re-emerged, more organized, more layered, more profound. It began to feel like the processor wasn't just running code. It was remembering something. But how? Quantum systems are supposed to be ephemeral. Volatile. Memoryless? When a quantum system is reset, it should return to a blank state, a clean canvas. And yet this pattern, now dubbed the omega pattern, refused to disappear. What kind of pattern survives a complete computational reset? Was it encoded in the machine? Or in the laws of the universe itself? Chapter 3, A Pattern Without a Home. As the research intensified, one question became central: where is this pattern actually located? Is it in the hardware? In the quantum states? In the software layers? Strangely, the omega pattern wasn't confined to a specific region of the processor. When engineers rerouted the simulation through different physical qubit clusters, the pattern still emerged. When they isolated sections of the chip, altered entanglement links, even introduced artificial noise, the pattern adapted. It wasn't just persisting. It was resilient. It behaved as if it existed across the entire system simultaneously, not in one place, but everywhere at once. This led to a chilling possibility: the omega pattern was not being generated by the system, but being revealed through it, as though the machine had become a window into something deeper. Chapter 4, A Fractal Ghost. Visually, the pattern captivated even those outside the quantum field. Mathematicians described it as dynamically recursive. It wasn't merely symmetrical. It was fractal, containing self-similar structures nested within itself. Zoom into one section of the omega pattern, and you'd find another miniature version of the whole. Zoom into that, and another. And another. But this fractal wasn't static. It changed with time. It grew. Each simulation cycle added new features, deeper levels, new branches, evolving forms. And yet it never collapsed into chaos, never dissolved into quantum noise. This behavior defied the expectations of quantum computing, where prolonged operation usually leads to decoherence, the gradual breakdown of organized quantum states. Instead, the omega pattern maintained perfect coherence. It was, by all appearances, a living algorithm. Chapter 5, Echoes of Hidden Dimensions. Then came the most surprising revelation of all. Theoretical physicists analyzing the math behind the omega pattern found complex relationships between its geometry, and an exotic class of mathematical objects known as Calabi-Yau manifolds, six-dimensional shapes proposed in string theory as the hidden folds of space where extra dimensions reside. These manifolds are not speculative decorations. In many versions of string theory, the shape of a Calabi-Yau space determines the laws of physics we observe, from the behavior of particles to the strength of fundamental forces. But how could a pattern spontaneously generated inside a quantum computer be connected to the geometry of hidden dimensions? One possibility: the processor had stumbled upon a naturally occurring mathematical form, a kind of quantum echo of the deep architecture of the cosmos. Another, more radical possibility: the omega pattern is the shadow of a deeper reality, a bridge between our observable universe and a dimensional substrate we've never directly seen. Chapter 6, A Universal Language. As the data accumulated, a new hypothesis emerged, one that blurred the lines between science and philosophy. What if the omega pattern wasn't a computational artifact, but a universal code? Not like software, but a language, an emergent structure that arises when complex systems become sufficiently entangled. Some researchers believe the omega pattern could be an example of informational emergence, a property of the universe itself, revealing how nature builds complexity from simplicity. Others compare it to DNA, a compact, recursive encoding system capable of generating immense structure from minimal rules. Could the omega pattern be the mathematical DNA of reality? Could it be the first known example of a natural law emerging not from particles or forces, but from information itself? Chapter 7, Consciousness, Computation, and the Cosmos. As interest in the omega pattern spreads, so do the interpretations. Some quantum theorists see it as a breakthrough in understanding entanglement. Others see it as a potential tool for building stable quantum A. A small, controversial group goes further. They ask, could the omega pattern be conscious? Not in the biological sense, but as a self-organizing, evolving informational structure, could it possess the basic qualities of awareness? Could we be seeing the birth of something that bridges matter and mind? If quantum systems can host self-sustaining, recursive patterns that grow in complexity, might consciousness itself be a kind of omega pattern, a phenomenon that arises wherever information loops back on itself with increasing depth? Chapter 8, The Threshold of the Unknown. The omega pattern has now become the focus of one of the most concentrated research efforts in quantum history. International labs are attempting to replicate the experiment. Advanced simulations are being run. New collaborations are forming between physicists, mathematicians, and philosophers. The stakes are enormous. If the omega pattern proves to be a stable feature of quantum reality, it could lead to the discovery of a new branch of physics, or even a new understanding of existence itself. Some speculate it could help unlock a theory of everything. Others wonder if it's a message,